Okay, so tonight I'm going to do something a little bit novel. I'm going to be presenting tonight from a version of LabVIEW you guys don't have access to yet. With permission, I actually did ask up the chain. Jeff Kadowski, founder of National Instruments, many moons ago, 2006, 2007 timeframe, somewhere in there, gave an NI week presentation in which he talked about the possibilities of asynchronous wires in the LabVIEW block diagram, something that Dr. T basically picked up and started popularizing as Jeff's wire, which I thought was kind of funny because I thought they were all Jeff's wires, but apparently somebody else must have delivered them and Jeff's only responsible for the nodes. So that's, I guess, what it must be. But this one is actually Jeff's wire. And what it was to do was, whereas existing wires are synchronous communication, this node operates, we go downstream, the next node operates, we go downstream, the next node operates. Asynchronous wires are meant to connect parallel sections of your code, so two loops running in parallel, and you need to get data from one to the other. Now we have, as broad general categories, three ways of doing that in existing LabVIEW. The first is with a refnum of some sort. Q refnums, notifiers, file IO refnums. You could use any number of references, and let's say you generate a point and it goes to both, and you pass the same reference to both loops, and then you have a read and a write. The second broad category is variables. You have a local variable, shared variable, global variable, universal variable. Those are the network shared variables. These are static points that you name and you can read and write from. There's a certain amount of configuration for buffering or for overflow and third-party handling and such. And then the third category is your functional global, your non-reentrant LV2 style global with the shift register that has synchronous call from both sides. Behaves a lot like a variable in many cases, but gives you the ability to have functionality encapsulated into it for synchronous operations and atomic operations. These three broad categories work. You're all very successful with them. We've built huge applications out in the world. And yet Jeff thinks they're mostly broken. And the biggest reason behind that is they don't actually show you what's going on in your application. There's a lot of setup overhead associated with some of them that are unfortunate. And so he wanted something that was better. Now, whether or not what I'm going to show you tonight is better is an open question. It's going to be in LabVIEW 2016. It was already in LabVIEW 2015, although not promoted, not announced. You had to know how to turn it on. We've got some various forums out there to talk about it. This is one of those projects where our R&D thinks we've got something truly better. And we're doing our darndest to make sure it is as robust and polished and well presented so that we can see going forward whether it actually is all that it's cracked up to be.
Hey, Stephen?
Yes?
You said if it's better than, will be up to us to decide or discover. Do you think that it's as good as?
At this point, I believe I can say with certainty that it has at least some use cases where it is a superior option. So Jeff recruited me to work on this project because for various reasons, but part of that was that I have a history of taking several advanced language features and trying to bring them as far down the user curve as possible. And when I originally signed on to this, I was thinking of it as a project to help the really big, massive parallel systems that I've been kind of involved with over the last few years with the active framework. And so mostly an advanced user feature. We'll connect some things and yada yada yada. But after several months of working on it and refining some things and changing some user interfaces and such, I'm actually coming around to the point of finding some very low-level, beginner, producer, consumer loops that are flat out easier for me to present. And I'm starting to see it as much more of a ubiquitous feature and not just a rarefied upper end of the spectrum. So we'll see. So this is I'm going to walk you through one of the shipping examples that we're planning on shipping here. This is our basic lesson in how the channels actually work. So this is, on top, you see a queue implementation where we do a in-queue, DQ, producer-consumer type of setup. And on the bottom, you see that we've replaced the queue setup with a channel wire. The most common complaint that we've heard so far, both internal and external, is the channel wires don't look distinct enough from regular wires. We've done our best to make them as unique as we can. They've got this sort of pipe effect. They kind of pop out a little bit from the diagram. You'll notice as it crosses the while loop border, there is no tunnel. These are not meant to show, these do not create a data flow dependency. So it's not like they're going through the gates of your loop as an input or an output. Instead, they're jumping over the wall and running across to the other guy because they're carrying data while the two loops are still running.
I still say you should use a bridge symbol for that.
And we've debated various things. All of the graphics that we've tried to put in there, nothing has quite appealed to people quite as much as just nothing there. Because it blatantly looks like that wire isn't inside that loop. We've also got these little flanges. This isn't in 2015. Little pipe flanges that stick out from the node. Little things that we've tried to do to help bring these wires and make you aware this is not your typical wire. We think if we had a richer graphics system that we could probably do a little bit better. So maybe in a few years, perhaps something along those lines could be done. But at the time being, this is what the pipes look like. Now, the pipes have a write node and a read node, and these nodes are where data goes in and data comes out. Now, the first thing I want you to see is compared with the work needed to set up a queue, and you know I'm fairly fond of the queues for various reasons. With the queue, you have to worry about lifetime management. You have this obtain queue that you have to configure and set up. You have a destroy queue that you have to somehow time and make sure you don't destroy too early or too late or forget about it and leak. That is folded away with the channel wire in much the same way that we were able to fold away memory management. So I always have to tell people who are coming from a CS background, LabVIEW doesn't have a memory garbage collector. We don't have this thing that sits behind memory and tries to pull through and find loose bits of memory and sweep them up. Instead, we have a compiler that, because it's a data flow language, we can say, oh, the wire starts here, it goes to here, we know how long you need that memory, we can then immediately reallocate it as soon as we know you're done with it. And that's what makes the in-placeness algorithm that some of you are familiar with when it sometimes goes wrong. It doesn't happen very often, but occasionally some of you have had reason to talk to us about it. This memory optimization, well, we're kind of playing the same game here, is we're able to look at this and say, we know we need a reference for the lifetime of this wire, and so we'll keep it around for the lifetime of that wire. It's not quite as simple as that in the same way that LabVIEW leaves memory allocated in case you re-enter the VI, things are already inflated. But it's a reasonable enough approximation for you to understand what's going on here. We know from the compiler side if it's going to last for this long. So in order to, just looking at, not even looking at the work needed to set this up, just looking at the finished product, we already have a reduction in the total number of nodes we need here. By 2 of the actual 2 nodes, and we've reduced the wire count because we're not trying to keep all of these air wires running around and keep things serialized and such. So when I run this, the 2 do have exactly the same behavior here, and I can stop one, stop the other, come down here, stop one, stop the other. They're completely analogous behaviors. Does that make sense to everyone? Okay. Now, the next one here.
Correct in saying that the channel wire, desk wire, and pipe, same thing.
Yes. Well, yeah, we don't use the term pipe anymore. Yeah, we don't use the term pipe anymore. We're calling them channel wires. The reason we're not just calling them asynchronous wires is, let me see if I can say this the way Jeff did. That would pollute the namespace too much. I may have some other things that are also asynchronous. and wires. So he's got some other things that he continually plays with.
Read and write bullets.
As a matter of fact, they are already inlined. So yes. So here's another one where I've got a, so this is a stream channel, and you guys probably can't see the little blips back from where you're sitting, but this stream of zeros and ones is typed there in the channel there. Here we've got a slightly different endpoint. This is, instead of read and write, just plain, this is write with Sentinel and read with Sentinel. This allows us to embed the stop signal directly into the channel. Now here's where we start getting even more power behind these channels, and this was really my viewpoint starting to shift. I tried a little experiment on a number of my customers, and both internal to NI and external. I took the standard producer-consumer shipping example that Darren wrote, that you hit the stop button and both loops stop immediately. And I said, convert this so that when you hit stop on the producer, the consumer keeps running until the queue is empty, and only then does the consumer stop. So nice, gliding to a normal stop sort of effect. And I asked a bunch of customers to do this, and 80% of them turned in a solution that had a race condition in it. And when I pushed them on it, they all knew the solution that's up here, the correct solution, but they thought it was too much work and figured they could get away with something more about. Not having to put this extra Boolean in and all these extra checks and yada, yada, yada. It was and all of this. And it's kind of funny, because every time we think we're smarter than the standard patterns for parallelism, we generally are wrong. And I say we because I put myself in that group. So if you're going to get a proper stop signal, we have to have something that puts that stop signal into the same communications channel. One of the #1 ways that you'll get race conditions in your code is if you try to have 2 communication channels, one for your data and one for your stop signal. I almost guarantee that if you've done that, your program has a bug in it. I don't know what conditions it will trigger under. It might be very rare and you might be very lucky, but it's probably there. One of the ones that will make you really cry is that one of the solutions that was turned in was from a guy who told me that it couldn't possibly have a race condition because that was the standard pattern for the National Instruments device drivers. We've since corrected that. It turned out that it was one of those that was actually safe in actual practice because of the way they were using it, but under various test apps that I was able to put together, it would fall apart. And I was like, we're just waiting for the first piece of hardware that exercises this differently. So, but with the channels, we're able to get this extra input and just bundle it in and let the channel handle it. And because of the way the channels are constructed, and I'm not going to get into the behind-the-scenes pieces tonight, but because of the way they're constructed, we're actually able to get away with an implementation that's actually more efficient than having a Boolean recorded with every value that goes in. So we're able to dodge the overhead of the copy into the cluster, pull out of the cluster, and all of that, that jazz. The signal is simply propagated as a sideband channel. And the way that the channels are constructed allows us to say these are atomic operations back and forth. So again, now on the front panel, I can run it, and I can stop one, and I can stop the other, and the stop signal is propagated.
So Stephen, does that immediately stop the consumer loop, or does it let it drain out?
And the Sentinel is actually a signal to let it drain. If you wanted to abort it, there's other ways of doing that. So let's kind of take a look at one thing here. I can right-click, choose Replace, and on any channel endpoint, and I can replace it with some of the other endpoints that are available. Right at the moment, you see a ridiculous number of endpoints with every little possible configuration that you could possibly have. We're going to pare this list down over the next week or so. We've been putting it in front of various people and saying, okay, which options do you usually use together? Which ones do you actually need? The reason we broke it out this way was so that we could make terminals required as much as possible. I'm a major fan of break, when you forget things, because I forget them. But if I choose the wire with abort, now I have
a terminal that has the abort signal in here that allows me to actually say, no, stop now, as soon as I get to that point. Yes?
So, I'm sorry, is it external, can they accept any data type, or is it limited to one channel?
We come to the crux of the issue.
So, if I was going to come in here and say, oh, I don't know, pick a cluster here, and I come over to its terminal, right-click, create, channel writer, and I would like a stream, and just basic write. Let's do a write with Sentinel just for the fun of it. And it goes. Now, this is running a little slow at the moment. We hope to have this faster by the time we get to the release. This only happens the first time you drop it. There you go. So now we get a channel out. We do the channel reader. Automatically matches it. And there's our channel that's nicely handling this new type of data. So yes, it is fully polymorphic. No, there are no X nodes involved. I may have mentioned that National Instruments was trying to get away from using X nodes at certain various points in our history. We're getting away from X nodes here. Matter of fact, it will do what X nodes don't do, and it will work with classes. Hey! Yeah, I know.
The 2015 one doesn't.
It was one of those requirements I told Jeff. I was like, if we're going to do this and I'm going to be on it, it's going to work with classes. So it did set the schedule back about a month and a half in order to do the necessary extra work. But, so yeah, we can instantiate all of those. And if you noticed, when I was looking in there, we have a fairly high number of the different types of channels. So the three big types, the three main types here are tag, stream, and messenger. Tags are equivalent to variables. Think DSC tags. We're trying to use terminology. This is terminology that's being standardized on across National Instruments, across a wide range of products. We're trying to get to a standard set of behaviors for all communication stuff. Some of you who are at the CLA Summit or some of the follow-on presentations remember, different protocols. Originally the 21 protocols for communication. That's now actually at 34 protocols because people have created new ones. We're actually trying to get away from trying to ever say we're going to build the one true, and instead we're going to build categories, broad swaths of things. Channels we don't count as another communications type because they sit on top of and use the existing communications. That's part of why the names we're coordinating the names to indicate what kind of work they're doing here. So tags behave like variables. Streams behave like queues. Messengers behave like, well, queues, but have some different semantics on the block diagram. The most notable piece of semantic is if I have a stream wire, which I happen to have here, and I try to drag this up here, and I wire these together, I get a broken wire because this channel wire cannot fork. Streams are point-to-point communication only. You have one reader, one writer. And while we're not really in the compiler taking full advantage of that at the moment, that opens the door for us to do some significant compiler optimizations on the FPGA in particular. Oh yes, these do deploy on FPGA. And eventually we think we'll be able to do optimizations on the desktop that we don't do today because we know one reader, one writer, and we can pair some things together. Messengers, on the other hand, are forkable, and you can route them to various places. The messenger, though, doesn't actually carry any data type you want. It's restricted to one data type, channel message, and has some advances in when you wire it up, it will automatically wrap any other data type in a child class of channel message. Channel message, you may, if you've worked with the active framework, you may recognize some of its features. It's acknowledgeable. It's droppable. In other words, if reader or writer quit early, the messages will get a drop signal so they can release any resources that they're carrying along with them or do a return to sender. Those are the three broad categories. And then under each category, there's some specializations. So messenger, stream, and tag. The accumulator is a tag, only instead of replacing the value, it adds continually accumulating results. There's a few.
Can you define what it means to add?
You cannot overload it. It only accepts numeric data types. It does restrict itself down to things that it will that it can actually do an add operation on. I haven't tried it with an array.
It would be interesting to have an accumulator where you could define what accumulation meant.
Yeah. Yeah, wouldn't it be? Common messenger is going away. We decided we didn't need it. It's just here in the build still. High-speed stream is a very particular stream implementation that I've done that has the same performance characteristics as the built-in queues, which regularly win the title of best communication sitting inside LabVIEW. They rank up against, they're up there in the top 3 generally, depending on which build of LabVIEW you're working with. The high-speed stream strips down to just as bare a platform as we can get, but it adds a little bit that you can't do with a regular queue. That's kind of nice. The high-speed stream here has got. Here, LabVIEW. There you go. Good boy. Has some things for doing normal stops, abort stops, and generally doing a really nice synchronization between your 2 endpoints. 6:15. Okay, so I got time. Yeah. Okay. Do I?
Well, maybe students before 7.
Okay. So skip through here, take a look at a couple of other things. So as I said, the tag replaces variable. So here's the tag. This is the exact same thing. This is incorporating the abort signal in with the tag. If you try to do 2 tags in parallel, or 2 variables, this is the classic one. People try to have a queue reference communicating their data, and they've got a local variable that's their stop signal, and they end up deadlocked because it reads the stop signal before it reads or after it reads the DQ, and then it reads the stop signal, and you're sitting there waiting. Great. Happens all the time. In fact, I've got one of the shipping examples. I actually built the race condition so I can show people once and for all. I'm shipping it with LabVIEW. This is a race condition. Because I'm tired of posting to the forums and trying to explain why your code is halting, but only on your production machine. No.
No. Good point.
That would be awesome. It should be.
Yeah. Okay, this is a choose your own adventure story where you go through and actually build up the example. So this is showing we can do channel wires. They go in and out of sub-VIs. They go in and out of call by reference nodes, async call by reference nodes. This is kind of fun. This is actually an async call by reference node, but the channel wire as an output is already on the connector pane because, well, the asynchronous communication happens even when you're not outputting. So if you're used to seeing an async call by ref strip off the output, these retain it. We've got a coding convention that we've started. If we create a sub-VI with a channel endpoint, we put the while loop glyph on the icon. It makes it a lot easier to read these things and consciously remember, oh, that's a loop. There's an entire loop in there. That's a parallel chunk of code. There's been some people who've complained that they're used to seeing parallel code stacked vertically instead of going horizontally. The only people who think of it as horizontal are the FPGA people who are used to pipelining. The rest of us aren't used to that. I've actually kind of begun saying that I kind of like this coding style where you introduce the S-curve because it kind of makes people feel a little bit more at home, and it's one more thing that makes the channel wire stand out. So now we're back to saying, okay, that's in parallel with that because it's nice and vertical, and the channel wire is doing something that no good data flow wire ever does. Never.
At least not without annotation.
Yeah, and prize for forgiveness in your change list. We can go through case structures. You get this fun thing here where I'm choosing here which channel to write to on each of the things. The channel wire just stops. Not going anywhere because you're not using it in that frame. You're using it in the other frame there. Like I say, graphically, I think there's enough differences that you're going to know you're working with a channel. I know a lot of people come to these pictures and they're like, that's just, I don't know how I'm going to fit an asynchronous wire in with all of my synchronous wires, and I'm not going to think of it right. The more I've gotten people to use it and try to play with it, I think there are enough graphical differences that it does stand out sufficiently. And honestly, you already work with RefNum wires, and those just don't work the same as a regular wire either. You've got enough oddities that you think of in your head in order to use them. I was concerned about this being in front of novice LabVIEW users at the beginning, but I've become less and less concerned about that as time has gone by. So if you ever get one that's so we do have to regenerate if you don't already have the system on your chain. This one is a particularly large CI. I think this is the large one. No, you cannot put them in a DVR. That wouldn't be meaningful. You can't put them in a global variable. You can't connect them to a shift register, uninitialized or otherwise. You can't carry them around. They're not data. It doesn't mean anything to try and put them into any type of data storage. It's kind of like saying, can you put a local variable into a DVR? You might be able to put a reference to a local variable into a DVR, but you can't put the local variable itself into a DVR. In much the same way, you can't put the channel itself into a DVR. Does that make sense? I'll wait for you to type yes, and I'm going to assume otherwise. Or if you type no, I'll come back to the topic. In the meantime, so here, just showing off the messenger channels can be forks. The stream channel cannot be. Tag channel can be. This one's fun. 2 writers and 2 readers on the same diagram, and they all just they're writing to the same variable, so they happen as they will. If you need a stream to go to multiple places, we do have the ability to right-click, insert, replicate, and that's a little sub-VI that says, okay, I know how to replicate the contents of the stream and put it out to 2 different sides.
Steven, the comment back was you can put a Q in a DVR.
Q is not an entity of the diagram. The Q is already a reference to the Q. You can't actually put a Q in. We created a reference for you for that. Do you see the distinction? I'm not trying to be facetious here.
That was the comment.
Oh, that was from there? Okay, all right. Yeah, I'm actually deliberately trying to highlight that we don't have a reference to this thing. If we were going to get a reference to it, it would be like a wire reference.
I think so his last comment was, how do you pass them to something that you cannot wire directly to? I assume he's asking, can you put it on a connector?
Well, they're on a connector pane. That's what these sub-VI nodes are, like the replicate that we're showing there. So there's their connection on the front panel there. So you don't interact with them the way you do RefNums, and you shouldn't need to. Like I say, they connect into asynchronous call by ref nodes. If you're trying to do dynamic patching, that's how you make them dynamic, is by choosing the endpoint that you're going to.
So 2 questions come to mind. Can you do that copy node for messenger? Send one message to 2 recipients?
Not at this time. We've not built a replicate system for the messages.
Under consideration.
Yes, but it lacks a use case, actually. In all of the interesting use cases, we have found that, like with the actor framework, we want to actually have a guy who receives the messages and is actively doing something with them. Like a standard replicate doesn't really make much sense most of the time. It's like he wants to do some processing and then decide who he's going to send them to. It's like very application specific. So a generic replicate hasn't been seen as much value as it was on the stream. If it is, we can add it.
Well, I was wondering about the to broadcast to several receivers.
Yeah, and like I say, that's usually just you have some place where you're writing to the three separate entities themselves. Yes.
The only way to use a channel somewhere is pass it on.
Yes.
Greatly colored. Right. They're created in one place. Right.
Well, they're not created in one place. They're created at the point of write. So
that's where you create them. If I go back to, I think it's lesson 5, it's the one showing the subject. So here, this one here, it's created
right there at the write, and it goes out through the connector pane. It's not, there isn't a secondary place where you declare your channels and then you use them somewhere. In fact, that's what we're trying to get away from is this VI uses it, therefore it's the thing that has it on its connector pin. And you can then
follow that wire up into its collar, follow it across, back down into the sub-VI, and find the matching read node.
That's the biggest thing to get around. Exiting the connector for that VI.
Yes.
Yes, it is not a synchronous wire. It is simply a connection that indicates there is communication between these two parallel VIs. Yes, that is exactly the raise your eyebrows, am I comfortable with this moment.
Can you put them in a cluster? So if you want to have 7 or 8 of them?
We have not given any ability to create
any sort of multiplexing at this time.
If I wanted to send 10 out, I know maybe no use case or I need 10 spots on my text.
Yes, and yes.
Okay. So they can see the wrapping the brain. But you can cluster. If you have an output that's channel, get an output from sub-VI channel, and an output that is regular data wire.
The output from the channel will fire at the very beginning because it's just a connection, and the data wire will fire when the VI finishes, just like it's always done.
Is there a difference in output channel?
Not really. We use them because it helps. It actually does help you with your semantic, reading of okay, this is clear. This is behaving like a read. This is behaving like a write. And so we use the endpoints correctly, but I can wire the backwards direction, and the compiler is happy with it.
Were you saying you can have both kind of wires coming out of a sub-VI, and that the ones that are synchronous will just wait for that VI to stop and then send it?
Right, because they behave exactly like they do today. There's no, they are not changed.
And they're not going to ruin the parallelism. So they just can't wire asynchronously to each other? Or maybe you said if the second one doesn't
Yeah,
stop.
you wouldn't. If you wire synchronously and asynchronously, then you'll be slaving the two to go in order. We actually have some test cases in our test suite that do exactly that in order to force like buffer flows, like make sure the write gets 3,000 writes before the read gets even a first chance. But that's kind of a odd test case. I wouldn't expect you guys to have that in real world. Sure. Yo. So,
I feel like the guys back in antiquity looking at the little steam engine that was the spinning around and looking at it going, that's really cool, and I have no idea what I'm going to use.
well, so let's take a look at that in the last few moments that I have here.
That's what I thought ever since Jeff rolled them out. I was like, that's really awesome.
So 2 things I want to kind of do here. So this first one is
the message handling system that you may be familiar with. So this is your user interface. This is your message handling loop. Note the wire that goes back into itself because it's both a reader and a writer. And this is your update for your status display. So you can think view, model, controller. If you've ever seen this example in today's LabVIEW, or 2014's LabVIEW, because you could have done this in 2015, technically, you have a whole bunch of code up here in the corner for creating a series of ref nums, sending them out to the various points. You have a block of code over here that's doing a bunch of cleanup, and it's very hard to see the relationship, whereas here, we're very clearly saying there's not a direct link here, there's a direct link here, and it's a one-directional thing. This passes back around.
We'd like to get this rewritten a little bit to use this through the event structure, like we did here, and we clean it up a little bit further in order to make it nicely symmetrical. But this kind of cleaned up a whole lot of code. Now, this next one is a lot of fun. So, how many of you have used Sound and Vibration Toolkit? A few of you? All right. So, over here, on this side, we have a whole bunch of DAC work. Over here on this side, we have a whole bunch of sound and vibration processing stuff. And here in the middle, we have this sort of absurd mess of notifiers to keep things going, and shared variables and stops, and it's this connective tissue between the two halves. If we compare that with this one, what's happened is we've now reduced that down to where the this thing is huge. And there we go. And we've folded a lot of that communication away into this channel wire here that is now just the communication all the way through. Doug thinks he can, Doug's the author on this, Doug thinks he can actually go further with cleaning up some of the stop signal work and incorporating it into the channels more directly as well. But this dramatically simplifies the legibility and the speed of writing this particular diagram, to the point that I've said that there are things that channels are a clear win over, and Doug is like, I'm never using notifiers again. The synchronization, the powers that the notifiers provide were much easier to express with the channels. Queues have always been fairly straightforward. Everybody gets what a queue is. Data goes in, data comes out. It's nice and ordered. Notifiers are a little fuzzier, and people are like, do I wait? Is it not waiting? They serve a very important need. And when I say to someone, you need a notifier here, it's because nothing else will serve. Well, now channels, which have a much more direct syntax, can serve a lot of those roles. If you want to play with this in LabVIEW 2015, if you search for the Channel Wires group on ni.com in the communities, there's a whole web page there that tells you how to activate it in your LabVIEW 2015. There are a couple of known issues. It's part of why I'm presenting in LabVIEW 2016 tonight, is that not only have we cleaned up the user interface a whole lot, we've fixed a couple of bugs, but they are completely viable and usable for a lot of things in 2015 if you want to play with them and get, kind of give some feedback. You've seen what they look like in 2016, so you know what we've already improved on and replaced. We're still looking for feedback. We're very late in the development cycle for 2016. I know that it doesn't seem like it from the date's still 2015, but we're trying to get ready to go into our beta cycles here. But just because we're in beta doesn't mean we're close to user feedback. In fact, that's for most features, that's when we get the predominant amount of it. But we do have a certain number of things that we can still refactor and a certain number of things we can't, which is why this feature went out in 2015, was to start pulling some of that in.
We start using this now. When we get around to 2016 next August, do you expect a smooth update?
I think the best thing that's going to be able to do is we are going to be able to give you instructions on how to upgrade your code that will be very direct. For the most part, it's delete your endpoints and recreate them. We're trying to figure out if I get a time window to do it, is to create a tool that will automatically do that replacement. It will load in 2016 and work, but it cross-links against your 2015 build, and we don't want that to happen, but that's one of those things that, because of the way the 2015 has happened, we got wrong. And we've renamed a whole lot of the channels to be names that people said needed to be more consistent, that sort of thing. So they don't just nicely remap onto the BI Live like you're used to.
Kind of puts the 2015 stuff in here, play with, start getting ready for.
It does, except that, like I said, we do know that there are drop-in replacements for the nodes that you would have. So it's not a nice, smooth upgrade experience like you would expect for a professionally released, actually marketed feature. That's what's coming in 2016.
Well, yeah, I'm looking at it from the recommended customer.
Yeah, yeah.
Because I can't in good conscience tell a customer that, hey, use this, and then 16
No, I wouldn't have you doing that, not at this stage.
Yeah.
Question from the remote. Can you pass the channel wire inside of classes?
No, it doesn't get bundled. It doesn't go inside anything. They're channel wires. They're not data.
Then another person said, I want to create a writer, then have end readers connect at some point in the future. Can I store the channel wire in some way so the reader can access that when they are created so they can start receiving data?
Meaningless requests. I assure you that that's, how do I say this? What you would do is you would simply write to the channel, and at some point the reader is going to read, and it will read the data that is now in the channel. So it's not that you store a reference to the channel and then eventually supply it. It's that eventually the reader gets around to reading, and it just reads.
He wants to know if there's a way to allow dynamic registration for the reader at rest.
That's call by reference node and asynchronous call by reference node. That's what I showed you earlier, yes. And
Other features, I was trying to keep.
Yeah.
Are there features that you can do with this that you can't in some convoluted way do with queues, notifiers, etc. today? Are we getting any?
Define you. No, there is nothing you could that channels bring to the table. No extra power that a programmer, a very, very skilled programmer in G, could not already do today. As a matter of fact, they are implemented out of G. That's how we. We've been moving more and more of the compiler and implementation side to G code, and this is one of the most heavily G coded pieces that we've ever done. But no, it is not. It does not necessarily bring any new power to the table. What it does do is bring it to the table in a form that you can actually manageably bite it off in a lot of cases that a lot of people could not do before, myself included.
My apologies if I had come across rude, but is there justification for spending so much brain power on this when there's so many other features of LabVIEW that are severely lacking? Really need help.
So Jeff would tell you, because he has at various points said this, that the language taking steps forward is a critical part of advancing LabVIEW itself. The more that, LabVIEW's bread and butter is making computer science expressible by scientists and engineers. If you ask the question, is there any point in producing a LabVIEW when we have perfectly good assembly code that someone can type on a keyboard? All of LabVIEW kind of falls into that camp. So this is trying to find a way that you can actually graphically evaluate, and in the sense of when I say it doesn't bring anything new to the table, it doesn't bring anything new to the table at runtime, but at code development time, at code checking time, code validation time, when you're trying to read a diagram, you're trying to see how many connections are on this. How many people have ever written a queue and hoped that there was nobody calling, dispose or release queue somewhere along the way that wasn't supposed to, or a global variable that you don't know who's all using that global variable, and you find somebody decided to hack something in. With a stream, you know it's going from here to there, and nobody's injecting anything along the way, and you can follow the stream and find where that data is actually being used.
It's easy to code in with putting the capsulating your queue in a class.
So that's one thing you can do, but that's not relatively easy. That's an entire class dedicated to nothing but that needs to be cloned for data types and things along those lines.
And a couple other questions from the audience. The same guy that was asking about why he can't stick stuff in his class commented, and these two comments are related, so he said, so I can't use this with active framework. Then the next person chimed in and said, having the channel wire only pass via the connector pane seems very limiting. What is the design?
It's not a design decision. It was a design goal. That was the entire point of the exercise, was that it went through the connector pane to show this is the two parts of the code that are tied together. That was the a priori aim, was to create something that went through the connector pane to tie together two parts of code. This is the reader directly tied visually, graphically to the reader. or the multiple readers, multiple writers in the case of the tag.
This feels to me very much like all those times in math or physics class where the instructor rolls out the notation. And the notation, I made this mistake a couple times as a undergraduate, that you look at it, you look at the notation, and go, this notation doesn't find me. This notation just expresses this in some other way, and I know how to do this other way with that. And the notation triggers a change in how you look at the problem. And good things, more things come from that than you would have gotten otherwise. And that's what this feels like to me. I haven't gotten to the point where this isn't just notation to me. But it feels like this is going to lead to actual proper work. This is diagrams, this is going to lead to stuff.
Right.
It's going to change how we look at LabVIEW code. And I'm not sure what that's going to be yet.
So you said you can't use it with Actor Framework. No. I have, well, he didn't. You parroted for him. You're my proxy, relay. No, you can't use it with the Actor Framework. I have rewritten the entire Actor Framework using channels, and restated the entire thing in terms of this. There's pros and cons. This is one of the probes for the channels, so I'm probing this stream. One of the things I can do is I can single step through the operations, so I can say step my entire program forward to the next read or write operation. So when we're talking about things you can't actually do with a refnum or things that you don't have the control over, these are things that we're able to improve on. It's all in the language layer, not necessarily in we've been Turing complete for years. And the question is how fast and how well and how cleanly can you express it?
Certainly seems like there's a great deal of code that could be eliminated by. Yeah, it's certainly nothing. The reason I asked that question, I was hoping I had missed something that was giving us some superpower we did not yet have.
I think it's going to trigger insight.
I think it will enable you to scale larger, and it will allow younger engineers to increase their parallelism much faster.
Let me ask it in a different way. Are we going to be penalized by using this over a standard queue? Is there overhead associated?
With the basic stream, yes. With the high-speed stream, no. The factor is actually a 1.1% or 1.1, whatever you multiplier. There we go. Thank you. 1.01. There it is. It is slightly slower, but that's because I put more features onto it. I can build one that is absolutely the same, but the value of the queues usually is that you put a whole bunch of other stuff on them, and so I went ahead and just put that as a fixed cost in there.
Question. One you bought is one.
Core 2.
Okay, core 2. Second one, if you can wire these up on the connector page, if you don't wire that out on all NPI wires,
so there's a great debate on the team right at the moment. It's split, and it may be whoever bowls last into the trunk who wins. At the moment, it's a runtime error. It says this channel leads nowhere, but we could make it an actual compile error as a required output. And we've gone back and forth, and we've actually had it implemented both ways at different times during development and frustrated different developers. So we'll see how that goes.
So we're running over time.
Yeah. So Darren needs to get up here.
Gotta let poor Mr. Madigan get up here and do his bit. So we'll parking lot. Any other questions? I mean, Steven, can you stick around when we're done?
Sure.
So taking other questions after that.